Hello, Professor. My name is ComputerVision2026. Today, I would like to present our computer vision mini project, which focus on parking space detection by image processing technique. In many places, such as shopping malls, universities, and public parking areas, monitoring parking space manually can be inefficient and time-consuming. Therefore, our project aims to develop an ultimate system that can detect whether a parking space is occupied or empty by a camera and computer vision technique. So this project demonstrates how image processing can help improve parking management and reduce human effort. Let me start with the problem state. In many parking areas, monitoring parking space still relies on manual observation by security guards or parking staff. This approach has several limitations. First, it requires continued human supervision, which increases labor costs. Next one is not practical for 24 hours operation, especially in large parking areas. And the third one, it's become difficult to manage a large number of parking spaces efficiently. Because of the challenge, there's a need for an automatic system that can monitor parking space and determine their status in real time. So, to solve this problem, our system is designed with several requirements. So the first requirement is detection accuracy. The system must accurately determine whether a parking space is occupied or empty. And the second requirement is single camera input. The system should operate using only one overhead CCVT camera, which make the system simple and cost-effective. And another one is the full automation. The system should work automatically without human supervision. This requirement ensures that the system is practical for real-world parking management. Next, I will explain the objective for our project. So the first objective is to detect parking space occupancy using image processing. The second objective is to classify each parking slot as occupied or empty. And the third one is to improve detection accuracy by combining multiple detection methods. Finally, we aim to visualize the result directly on the parking lot image, so user can be easy to see which space are available. Now let's look at the process of our systems. Our parking detection system follows several steps. First, the system loads the reference image and parking image. Then we apply the image pre-processing, which includes the converting the image to grayscale and applying Gaussian blur. This helps reduce the noise and improve the detection performance. After pre-processing, we perform edge detecting using the Canny method to identify object boundaries. Then we extract the region of interest or ROI for each parking slot. Next, the system calculates the contour area and white pixel count within each parking space. And finally, the decision rule is applied to determine whether the parking space is occupied or empty, and the result is displayed on an image. that I will show you later. Now I will explain how parking detection code works. First, we import the requirement libraries. We use the OpenCV, which is a popular library for computer vision and image processing. We also use NumPy for numerical operations and matplotlib to display image. Next, we load the parking image using the cv2.mread functions. Since OpenCV reads the image in BGR format to be the RGB format, using the cv2.cvt colors, so it can be displayed correctly with the matplotlib. After that, we resize the image to the 1004 by 600 pixels to make the processing more consistent to easier to manage. Then we start the image processing stage. First, we convert the image into the grayscale. This simplifies the image by removing the color information and keep the only intensity values. Next, we apply a Gaussian blur. This helps reduce the noise and smooth the image, which improves the accuracy of edge detection. After processing, perform edge detection using the Canny edge detector. This technique highlights the edge of object in the image, such as an outline of cars. We also apply the morphological closing operation using a 5x5 kernel. This helps fill small gaps in the detection edges and make the object boundary more continuous. Next, we define the parking grid structures. In our example, this parking lot certain 2 rows and 12 columns, which means there are 24 parking spaces in total. So that means 2 times 12 equals 24. And we also define parameters such as the starting position of the click, the width and height of each parking spot, and the gap between space. Then the program loops through each parking spot using net loop for rows and columns. For every parking slot, the program extracts the region of interest or ROI from the edge image. This ROI represents the area where the car might be parked. Inside this ROI, we use the contour detection to find shapes and might represent a vertical. The program then calculates the large contour area in the region. If the contour area is larger than the predefined threshold, which is 1500 pixels, the system assumes that a car is present and mark the parking space as occupied. Otherwise, the system considers the parking space empty and increase the count of the free space. The program then draws the rectangle around each parking space. A red rectangle indicates an occupied space, while the green rectangle indicates the empty space. So the system displays the number of available parking space using the cv2.putText. So it must write here. Wait. Oh, here. It's here. So the final result is shown using the matplotlib, where the parking space and their status are clearly visualized on the image. This process that allows the system to automatically determine which parking space are available using computer vision techniques. So here is the result of this program. I have two results. For this one is the first one is and here is the second one, which is I add more car in the parking area. In the word image, the system successfully detects the most parking space and classify them as occupied or empty. The green one rectangle represents the empty parking space, while the red one is represent the occupied space, where the vehicle is detected. In the first image, the system report that 13 free space out of the 24 total parking spot. This one. And the second image is the 16 free space out of 24. Overall, the detection works correctly for most parking space systems, can clearly identify the presence of vehicle and mark them accordingly. But however, there are some cases where the parking space containing a vehicle is incorrectly detected as empty, like this white car here. This means the system products is a false negative, where car is a present but not detected. There's a several the reason that must be possible. The first reason is some vehicle have colors that's very similar to the ground, which makes it harder for the age detection algorithm to distinguish the car from the background. And the second reason, the lighting conditions and shadows in the parking lot can affect age detection, causing the vehicle boundaries to be less visible. And the third, the detection method relies on contour area threshold. If the detected contour area is smaller than the predefined threshold, the system may classify the parking space as empty even though car in presence. And finally here slide slide misalignment of the parking slot ROI or region of interest may also cause the system to miss part of the vehicle. Despite these limitations, the system still demonstrates that image processing technique can effectively detect parking occupancy in the most cases. Now I will discuss some observations and limitations of our systems. The system shows promising results in detecting part vehicles. Age detection and contour analysis are effective in identifying the shapes of vehicles. The grid-based ROI method also allows the system to monitor multiple parking spaces simultaneously. However, there are still some challenges. For example, if the vehicle has a color same as the ground, detection accuracy may decrease. And lighting conditions and some of shadows and reflections can also affect age detection. In addition, if the ROI placement is incorrectly, it may cause what's called misclassification. These factors indicate that future improvements are needed. For future improve for the future improvements, we propose several ideas. First, we can integrate the deep learning models such as YOLO or Mars RCN into improved vehicle detection accuracies. The second, the system can be extended to support large parking lots with the many parking space. And the third, instead of processing still images, the system can analyze in real time video streams from CCVT cameras. And finally, the system could be connected to the cloud or IoT platform, allowing parking information to be displayed on the mobile application. Would help the driver quickly to find a available parking space. Now, to conclude our project successfully implement to a parking occupancy detection system using computer vision techniques. The system can analyze parking image and determine whether each parking slot is occupied or empty. Several key techniques were demonstrated in this project, including with the image processing using grayscale and Gaussian blur, age detecting using the Canny algorithm, contour detection and area analysis, decibel-based classification. This system has potential application in smart parking management, parking availability monitoring, and smart city technology. By automating parking detection, we can improve efficiency and reduce traffic congestion. So thank you for your attention.